Yeah, I'm looking at the responses. If you want, you can answer it, I think, a couple of times. It doesn't matter. If you want to write something else, I think you can open it again. I hope that's the case. Open it in, what's that word? Incognito. Someone wrote, I like playing gotcha games without spending money. That you've got so much patience. Whoever that is. Yeah, I know. I think all the 3D plays are fake. What gotcha game? Which one do you play? Yeah, Genshin is probably the most popular, no? Genshin. Right. There are, I think everyone has responded, no? Because there's 24 people in the room and 23 of us are Eddie, me, and another me. Okay. And there's a person yelling under my window, like constantly for 5 hours. I'm slowly going crazy. Okay. I'm gonna have your quiz soon. Also, anyone who's joined, please go to this Google form and respond to the question. Seems like everyone's responded. That's great. Yeah, if you can keep responding, it'll be fine. Basically, we're going to try a few of the things that we taught last Tuesday. So we're going to be using a couple of new libraries. And we're still going to use Streamlit. Because I think, I don't know, you guys liked creating more interactive data science stuff as opposed to just running Jupyter notebooks, I believe. Felt like it. I like Streamlit too. This time it's gonna be, I'm gonna also be, because I've generally planned, I have planned a little bit, but I'm gonna be winging it to a certain degree because I haven't prepared fully. I've done this before. So why don't you all do the quiz quickly and we will start. Okay. I am going to, yeah, so please go ahead and do the quiz. We can get started. So we are going to make a copy of this file. I'm going to share a data set with you all. Also, can you all hear me properly? Everything, the sound and everything is okay? Sounds good. Okay, where is Discord? Yes. So under additional resources on Discord, are you all done with this quiz? I'm going to have a Jupyter notebook just to try stuff. Then we'll move it to Streamlit. The dataset I shared with you, have it in the folder. Okay? Okay, so everyone good? We should start. Thumbs up if you, not that I see the thumbs up, but yeah, I can read chat now. I actually have chat in front of me. Perfect. The quiz is done. Y'all have the dataset? Maybe, can you also send it as an announcement, please? Just if anyone doesn't have access to it. Okay. We are good to go. So the plan for today is to use something new. So follow along, code with me. We're going to have a few separate things to do. The first thing that you all want to do is to get this library, install the sentence transformers library. So under installation, really you can, we went through this last time, so it's pretty much the same. If you have a virtual environment, just use that, activate the virtual environment for yourself. You're using your base Python, make sure this is installed. If you use Conda, you can install it. Whatever you want to do. We want to be able to see the data. Now I'm going to take it slow a little bit because I've got feedback that sometimes we move to SAS. So I'm going to be a little bit slower. I don't know how much we're going to make in class, but it should be fine. So just like always, the parts that we've done a ton of times, I'm just going to type. Okay. So you should have these three imports work for you. So thumbs up or yeah, whatever, type in chat if you can get these four. If you have questions, let us know. I want to see if you can, if just the import has worked. Anyone got problems? Please do. We're gonna work with it. Cool. Spelling mistake happens. Yeah, just install sentence transformers. And again, I'm gonna just show you where you can see how it's installed. It's sentence-transformers is the library. If you get it installed, you should be able to use it. Okay. I think we are looking good. So what else do we need to do? What I want to do is basically to get a model from Hugging Face. And it's just much simpler than what you've been doing up till now. You're just going to use the name of the model. I will send this into chat. There are a ton of different models you can use. You can use BERT, all sorts of different stuff. This is one of them. It'll download it for you. And now you have a language model loaded into your system. This is a small one. And this is not a language. So as I explained last Tuesday, we have these encoder-only models. Encoder-only means it can encode text into that virtual high dimensional space as a vector. But it does not know how to generate text. This is one of those. Okay. We're going to do a very simple thing. We're going to, now that we've loaded this model, we're going to first try to see if we can just get one example, the vector from one example. So we're just going to write test and create a string. I have been playing a lot of Slay inspired to, but also like what's in it. So write a sentence for yourself. Really, this is going to be you just calling a function, model, encode, test. And you can call this query and value. This is how this model represents your text. How are we looking? Please use chat to interact with me so I know the pace. I know how to keep pace. We balling? Oh yeah. That's good. Everyone's caught up. Nice. I'm at Ascension 7 only, just a small detour, but I'm at Ascension 7 just for with my brain is so tired. The dude that does this sort. I forget. Okay. So now, so we have the embedding of our query text. Now we can also embed everything else. We have the model, so we can just say document embeddings. You can also still use model.encode, and you will just, let's just create a variable for it so that we know what we're doing. Oh, this way it copies. Yeah. Okay. So I'm just going to say text equals df activity. And I just happen to know that it needs it as a list. So I think it works better as a list. I believe we can just get the list of those. It's the same order as our data frame, so that's how we use it later. You need to pass this to your model. Again, as you can see, it's creating now an array of, for each of those tags, it's created an embedding vector. If you run this, yes, let me just get rid of this as well. So now we're basically there. We just need to create a cosine similarity and calculate it. So it's you can find, I think the, whatchamacallit, sentence transformers does the cosine similarity, but it's simple enough. So let's just create a function that does it for us. We can create a function called cosine similarity matrix. And then you need two inputs, B. A and B are both numpy and the arrays. I believe in Python now you can just go something like this. You just tell the user what you're expecting the inputs to be. Okay. Really, the cosine similarity is simple, is basically the dot product of the two vectors, right? But as you remember, the way we talked about it is that you first would normalize the vectors because you don't care about the length. You just care about the angle between them. Basically, when you calculate the cosine similarity, you're doing the dot product of the two vectors divided by the length of both. But because we only care about the normalized vectors, so the length of them, normalization basically means dividing the length of the vector, dividing the vector by its length. That becomes like a length of 1. Okay? So you don't need to do, you just need to do the dot product. A norm equals A divided by NP, then out dot norm A. And I've looked this up. You just do axis 1, feed bins 2. And do the same thing for B. B divided by n out dot norm B axis 1 cube bins. I don't even know what cube bins is, but it works like this. I want to show you that it's a really simple concept. So all you need to do is to return a norm, and apparently that's your function. Transposing the normalized B. It's an add symbol. It's a dot product. You can use this for doing dot product basically. I learned this today as well, but it's interesting. Okay. Now, again, you can go look at how specifics of why this is calculated like this, but it's a simple thing. Try to remember the idea behind it. So now we have, just kind of for making things nice, I'm just gonna bring the function just before everything else so that we're not having, I like to keep things tidy. So now this is the rest of it. You can just type after me. You calculate the sims by passing the vector as you created, query, embedding. You need to reshape it because both of these need to be matrices. That the first one is just a vector, and then you do the document interface. What we get is a bunch of similarity numbers. It's a flat list of similarity numbers. But look, it's because it always returns a matrix. We just take the first item of it as well. And then you can, because it's in the same order of the data set, you want to see, these are the similarity of everything, every text in our data frame to that query that we sent. Okay, so we can create a new data just so that we don't touch the original data frame. We can create a new data frame and then just say similarity equals sent. And then we can sort it from highest to lowest. And then let's just see. So my query was, I have been playing a lot of Slay the Spire 2. And now we can, okay, what's happening here? For some results, this is an in-place sort. So these were the most similar based on this sentence, based on this model. It's not bad, right? Like cooking is farthest away. Webtoons and like the video game gotcha games and Slay the Spire 2 is there. The thing is, I said watching movies, so it literally just is getting that, right? So watching TV shows is there, and it doesn't even probably know what Slay the Spire 2 is, but it's close to it because I'm doing playing. I think that's how it's doing the thing. Okay, we've done it. We're essentially are able to have a query and then find from a set of documents the best, the closest based on that model. Now, it is very much the fact that we all just implemented something called semantic search. And this idea is actually the basis of a lot of these newer AI technologies. Because AI, for example, when you want to ask questions from documents using an AI, it does not know the documents. Your query needs to sort those first somehow. They probably do more advanced ways of doing this with more complicated logics. And then they sort them. And then they feed the top documents to the AI system. And then that gives you the response. Okay? That is the idea. So now now that we've done this, we can quickly, I'm not gonna just type more quickly, right? But hopefully is everyone done up to this point? So let's just quickly, thank you all. Let's just quickly then do this Streamlit version. Import Streamlit as SC. We need to do some things differently because we want to make this interactive, right? Import pandas as PD. Oh my God, I swear to God, I don't need your, oh yes. Import numpy as NP. Why is this, what the, am I typing something wrong? What? Do this for imports for some reason. Requirements.txt. Yes. We just install these. Didn't you just install these? I don't even know what this autocorrect is supposed to do. This should work. But try to install it yourself. I mean, you don't need requirements.txt. Okay. So like we can really, I'm just gonna do the, we can just load the model like we did here. We're going to use this model repeatedly. So I'm just going to paste it here. Okay. And we can load our data set of documents here. Okay. So now we have both the data frame and the model. Because later you might use larger things and repeat it, like you can, because you can upload stuff, okay? This is a better way to create your functions. Okay? So you create a function that embeds the text for you and returns the results, because then you can repeatedly use it. Then we can do cosine similarity. We already wrote it, so copy and paste. This is basically model.encode, just exactly like the one that we did here, right? Where is it? So that's exactly like here. Actually, let me just, so that it's more clear, I'm just gonna, and then return like this. Then model to return the embeddings. We want to use this model. So I've been looking into how we can use larger data, right? So this is the way, this is the way you want to do things. So this line decorator that you put past the, before your loader function, gets Streamlit to cache the encoding. So if you want to do it next time, it doesn't need to repeat it. Okay. So I'm just going to bring back the comment here so you know. I never taught you this. Okay. This is what you need to do. So then we can have the query and call it, make it, this time the query is not going to be a string. It's going to be a text input, and say, find your favorite activity to find students that match you, I think. Okay. So let's call a rerun. The first time it's going to take a little bit. And oh, ST. So I'm going to back. So now we have our text box. We're going to use the what's inside of this to run the query. The rest is easy. The rest is very easy. You can say if query we have our cosine similarity function, and we have our model, right? So we can just say we want to encode the models here, right? The document embeddings, because you're going to repeat it. You don't need to run this multiple times. So I'm just going to come back here, get our document embeddings, and model encode text. Oh, let me just, you have the function, so we bring it here, and we use our embed text. And then we do model. And the text should be df text. I think it's going on. I swear to God, today is something is messing with me. Where? Moodle? That's one. Well, what is this? Oh, what? Def. Oh, see, I caught this. Yeah. Thank you. Okay, so now we have our document embeddings. Inside of here, we can just do query embeddings, model dot encode query. The reason we're using this function here is so that it can cache this data if you want to use a larger data set, which you might. And then this is exactly the same. So I'm just going to copy and paste from the other. Okay, and then result equals df copy. That's easy enough. Honestly, let's just copy and paste the rest. We're just going to do something a little different. We're just going to say results equals, let's just say top head, let's just say 5. Let's just get 5, the top 5 connections. And then we're just going to do st subheader most similar activity, right? And then you just go, you can do something like this. You can write a for loop. So you can just say for I row in results of iter rows. This is how you iterate over the results. You can just say st write row. Hopefully I did not mess things up. Okay. Always rerun. Okay. In our data frame, the thing that's text, we should type activity. This is activity, and where? This is activity as well. Also, we need to do something else. We need to cache the model load as well. I'm gonna copy and paste here, because every time you save, it's reloading this. So all I'm just gonna do is just say load model. So it's just gonna do this once. My favorite activity is playing video game. Okay, so query embedding is not defined now. Let's fix that. What's query embedding? That needs to do these. Save. Let's go back. All right. So let's change it. Let's just do, I like to play basketball. Ice hockey came here. I think play is doing that thing. I like these donor kebabs. See, it finds without you having to do the search. It does it for you. You've just implemented semantic search. Okay. All right. Yeah, semantic search is pretty cool. So you can basically implement sort of a lot of interesting searches. And then the better the model, the better this sort of semantic information. As you can see, it was doing video games, right? By mistake, when I said play basketball, play video games was the closest. And I think the longer the sentences, the more information it has. The reasoning is just my speculation, right? It's based on the data and how it's trained. So let's just ask again, there's no rule, right? These models are trained on large amounts of data, and this is how they represent this text, and this is how it's going to. So it's not an accurate science. But why don't one of you give me an example sentence so I can type, and let's see, and let's talk and just get a sense of what's happening. Mustafa, no, it's not reading keywords at all. It's taking the whole sentence. It's giving you a vector based on what it's learned. This is, as you can remember from early in the session, this is actually a black box model. You don't know what it's doing. You can guess, and there are ways to interpret, like to make it explain it, but we don't know. So let's just say I love writing books. It does an all right job. Yeah, it does that. This is a really powerful technique. You can, and honestly, the reason I'm showing you ways to build these into interactive systems is that maybe you go for an interview, right? You might have this deployed and just show them something interesting, something. Jupyter notebooks are useful, but you can show them that you can build interactive things that does something interesting. We're actually going to try another thing. So this is where we are. We're going to take a break, 5 minutes. However, go and install Ollama on your computers. Ollama is now, if any of you have an old computer, we're going to have problems, let me know. We're going to figure it out. But I think we're going to try to use a very small model to see how we can build some zero-shot classifier into an interactive thing. Yeah. We're going to try with Ollama. We're going to use Ollama to do some data science stuff. Okay? So go to download. It's going to take a little bit. Install it. I'm going to be back. 5 minutes, okay? 5 minutes. Try to download this. Maybe please help them if they have questions or something. I am back. Do you all have Ollama installed? For those of you who have installed it, I'm trying to find the model name. Now, Ollama is just like Hugging Face, you name models. So you can, we're just going to use Gemma 3. Yeah, if you have better models installed or something and you know what they are, feel free to use those for sure. And if you have the GPU for it, I believe the command we want to use Gemma 3 4B. This is the smallest reasonable model that I could find. There's a lot of things, but now let's just, if you have it installed, run this command in your terminal. If it downloaded, then you should be able to follow along. Okay. Is it downloading for you guys? We're trying to do this in 20 minutes. We're trying to build like a zero-shot classifier based on this model. So I'm gonna actually create, just for testing, we can just do it in, I'm gonna create a new notebook and I think I have Ollama, and you can I think you can just also install the Python Ollama library. Ollama Python. Very large pip install Ollama. Just to test that you have it, you probably downloaded an Ollama interface. Try running, just saying, hey, hello, or something to the model Gemma 3.4b. And let's see if you get a response. Okay? This is very similar to all the other API models that you can use. But Ollama chat, then you need to give the name of the model, right? Now, I've been practicing with using images because Gemma is multimodal. But let's just say the best anime from the world. Just see if we get a response. You should be able to run this in your Jupyter notebook, and you should be able to get responses. The first time you run it, because it's loading the message, it might take the model. It might take a little bit. Done. Okay. So we can see the response. Message. Content. What's the best anime? There is no single definitive answer. Blah blah blah. It's One Piece. What are you trying to tell me? Full Metal Alchemist. Can I copy this? And I just want to read. Okay. Now, is it paste as markdown? What? Anyways. Oh, maybe. Oh, I got it. I need to print. I think. Yeah, this is better. Oh, it's actually markdown. So now let's copy this and take it to my document. It says markdown. Boom. The Titans. Oh, the Titan is not the name of the anime. It's Full Metal Alchemist. Attack on Titan is awful. It's a really bad anime. Okay, One Piece is here. There you go. The model is good. Okay. I'm able to run the model. Were you guys able to run it? We good? You were able to get a response? Okay, now we're going to go into our app.py. It says failed to connect to Ollama. Can you run Ollama in your terminal? The best way is to copy and paste that into Google, the error, and see what it says. But I think you can run Ollama run something, the name of the model, and see if it runs it. If not, it should be, yeah, Ollama should be running, yeah. Open the app. When you don't download it, open the app. It should be running. Then you can use it. Okay, so we're gonna be doing something. Yeah, that's probably why. Okay, I'm just gonna create two tabs. So we've done this before. st.tabs, and the first one was semantic, similarity, and then the second one is going to be zero shot with Semantic. Okay, and then I want to take everything with tab 1, the model stuff. We're just going to take it to tab 1, and then we're just going to say with tab 2, st.write, let's try using Gemma. Okay, let's see if our app, it takes an array. So instead of just having 2 inputs, you need to have an array of items. This still my favorite activity is watching anime. This still works. Now we want to do Gemma. Okay, so it's going to be finicky, but we can then, because I want to like speed run this now. Okay, so just say labels text equals st text area categories, and then give it like height. Okay, so under tab 2 we want to do something like this. So I just want you to, this is what I came up with. So we want to ask people to write exactly this so we can parse it. Then we can figure out something. Okay, so let's just say we want to do as an example category names and category descriptions equals an empty array. Okay, and then we're going to parse this text. So we're just going to say for line in labels text dot strip takes like white text from it dot split. We're going to ask people to write it with new line. So we're just going to do this and then say if not in line. So you're trying to say if it doesn't have it, just continue. You do nothing, right? Then description equals line split. Okay, now you do category names append name that strip, and then you do category description append this dot strip. Now if I typed everything correctly, you guys can follow me. I haven't. Descriptions. Okay, now I'm just going to say st-write category names st-write category description. Okay, I think it's right. So anime, movies about anime. No. Favorite activity of someone is anime. And then movies, favorite activity of someone is watching movies. Okay. First, favorite, all other favorite. Did it work? Code. All that if it's working for you, good. But honestly, we're trying to do prompt engineering, okay? Because honestly, I'm like these parts I'm live coding. So never mind. Let's just do st-write labels text and see what we see here. Okay. That's fine. So I'm just going to write prompt and then f string. Your task is to classify any given document based on the following categories, and then you do labels, text, right? So you're passing something that the user is doing into the prompt, and then you say your output has to be a JSON. You can do better stuff, I'm sure, but this is just a crude way with the following format: text, category. Okay? And then we're just going to say, here are the texts. We're just going to say, here are the texts that you should classify. Has to be an array of JSON objects. And then just tell it like this. Oh, we need to escape this, I think. How do you escape something in that string? How do you escape in F string? You simply double it. We're almost out of time, no? What screen? 10 minutes left. Okay, I don't know. I hope this worked. Let's just see. Let's just go for it. Okay. This is our prompt. We need to also have the text equals df activity. I'm just going to say to list, and then I'm just going to do 5 of them. And then let me just see if this is working. Let's do inject equals join, and then you just go text. This puts new line between all of your texts, and then you put the text here. If it works one shot after me trying to just do this, it'll be really good. So you just generated your response. We come back to our Jupyter notebook and give it the thing that worked. You bring this, we put it here, and then the role is user, and then we just paste prompt here, okay? And all we need to do, let me just delete these parts that we don't need, delete this part that we don't need. And then you're just gonna say, for now, because we don't have time, st write this. I'm gonna hold my fingers and toes crossed. So what's the error? Ollama is not defined. That is not a problem. We import it. How do we import it? Import Ollama. Is it fixed? All of them are others. So let's see. Let's look at prompt. Just to debug. Bouldering. Okay, I'm going to change the prompt. The original text. And then the category. The category you assign to it. Okay, let's try again. It's being a bit stupid. Oh. Okay, what should we do? I'm just gonna tell it I'm not gonna give it double strings. Do like this. How about this? Boom. Okay. We can create new categories. We can say sports favorite activity of someone is sports. And then boom. And it's going to run it again. Bouldering is sports. Okay. Now you should run it on one. It does better. The JSON kind of is looking all right. We were able to create interactive machine learning with LLMs with a little few lines of code, and legit you can change this with any of the other libraries. You can use OpenAI, you can use, but this is the basics of it. So you built a classifier without having sample data, and it works to some extent. Any questions? So you try, if you have a decent GPU, try different models, try different tasks. You can now really build interactive machine learning apps. Just your prompt is here, you engineer it, you put the things you want it to do, you give it the data that you need to do something with it, and then you run it and you get the results. Okay? Honestly, you want to try something before we go in 1 second? Instead of having this text, I'm just gonna say text equals st text area, your input text, right? Height, and then I'm just gonna, and then I just put it as, just because it's gonna break, I'm just gonna put it as a list because our code is going to break. I need to do it only 1 minute, right? So now, hello, my favorite, I love to watch One Piece, the anime. Boom. So it's this, it categorized this, which to some extent kind of works, but you can change this, right? Love to drive fast cars. Gonna hopefully do others or something. There you go. Perfect. Okay. We were able to quickly do stuff. I'm gonna share this with you. Hope you enjoyed it. So you have 2 types of interactive machine learning apps. Do you have other questions? I'm not going to give you lab tasks. You have a lot to do, but build something with it. Build stuff. Build data sciencey stuff and use that. Okay? Questions before we adjourn? Where do you submit proposals? We're going to open, maybe, do you respond? Do you want to respond to that?
Yeah, we will open slots assignments under the final project part on your assignments page.
So we have a question. What would be the efficiency of categorizing with LLMs compared to simply embeddings based with a sentence transformer? Good questions. There is a way of actually classifying using embeddings, as I told you in class. You can actually take the embeddings and build a random forest to classify as well. That also works. So there's a bunch of different ways to do transfer learning. What would be the efficiency? I think this Gemma model is going to do better because it's a larger model. It understands text better. But if you had a large transformer like embedding model, it could work well using that method as well. I'm going to share the code that we just did in class in a Git repository and share with you. So don't worry about it if it was just downloading. What would be the proposal look like for grad students? Is it the same thing? Yeah, it'll look exactly like the same. We can send an announcement for you as well. However, you can use your lab or research for your thesis or something as the basis. You follow the same format, even act like a client, do the same thing, but make it your research. You can use it as on your own. Okay? Any other questions? Okay. Thank you so much. I had a lot of fun too at the end. I actually got a bit more excited after we got this down. So I hope you guys really next week, hopefully share something, bring stuff to show. If you can, it'll be really fun. I honestly, tomorrow, I'm just gonna give you all a break and myself a break as well. My brain is fried with all the things that have been going down in Iran. So no lecture tomorrow. Let's skip it. Work on your proposals. I'm gonna post this video. We're gonna catch up next week on Monday. Cool. Thank you. I'm excited. Thank you for giving me nice comments. Perfect. See y'all next week. Bye bye.